Hi, I'm taking Paul McWhorter's AI for Everyone class, and we're on lesson number 17, continuing with face recognition. And this week we're talking about automating the process using the OS walk command. Our homework was to split it up so that we can get the encoded faces and then save them on as a file, and then have another one that'll run over and over whenever we want, and we don't have to do the encoding each time. So that was pretty interesting to do that and save all that waiting we do at the beginning. So also did a little bit of extra credit at the end. We'll talk about that in a little bit. Let's get to the code. So basically, encoding was fairly straightforward. You import your libraries, you create a couple of lists, names, and encode known faces, and then basically go through what Paul was describing on the video. Did that, and then open it up and dump them, pickle, put them in the pickle dump, and only thing we have to know is that we have to keep our order the same when we go to unload and load them back on the next program. So we got a couple of print statements in here to show us our progress, and then when we finish up, we'll go ahead and run that. So you can see we're just printing to the terminal each time one's done. And then at the end, it'll tell us that it was saved and we know we're done. Program stop and everything will be done. Faces saved, so we're good. So basically that's all that program has to do. So we'll go to the next one. So this one, like I say, we import our same OS and pickle and our normal face recognition CV2 file. This time we're opening it for read, and we're loading the two file names in the correct order. So now we have our two lists back that we need, and don't have to walk through all them again each time. So that's cool. And then basically this is we're doing for the unknowns, we're doing the same thing over again, getting our path, our full path and everything. And then we go into our regular face recognition stuff down here, and basically that's all the same. And this way we're just walking through each of our unknowns. And I'm down here, I'm just resizing them to fit the screen. Some of the images were really big and wouldn't fit on the screen, so you got to resize them a little bit. We're using the wait key down here to actually go to the next item in the list, so keeps the list from just going crazy. So we'll run that and see how it works. So basically, we didn't have to do the encoding, so we're good. So basically, we did this all last week, so I'm just gonna pause through here. Still, like I say, each time you do it, it gets some of them right and some of them wrong. Wrong, right, wrong, half wrong, right, 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 and we're done. So basically that was our homework for the week. So that was kind of cool. So I decided to take it a step further. So I was figuring out how to capture part of the screen to so that we could just like run a small window with a browser window with like a YouTube video or some list of photos or something like that in it, and try to pull them out that way. So I looked around for a while and found what we needed. So basically this is our thing. So the only extra library that we needed, we already actually had imported it when we did the face recognition, so we didn't have to do the pip install on it. So, but we do have to import the image grab. That's what's grabbing our image off of it. So basically, that's it. We wanted to keep track of our frame rate, so you'll see some weighted average to get the frame rate stuff done. This is our capture width and height. Didn't want to use the full screen, so we wanted to be have a decent size, so it wasn't too big for the software to take care of. I ended up putting a couple track bars on, but they ended up being of little use, but I left them in there. I'll show you a little bit of how they work, but basically they just move it around. Like I said, we're going to put our recognition part on the right side of the screen, so our window that we need that we're going to be checking is going to have to be on the left side. If you overlap them, you just end up with that like infinity mirror type thing where they just go crazy. So didn't want that to happen. So basically did the track bars, and then we had to open up our encoded names that we already know. Did some stuff for the frames per second, and taking care of the track bars if they move. So basically the track bars are getting the top left X and top left Y position of the region that you want to, of the main screen that you want to capture. So that basically it. And then your bounding box is going to need the top left and top right, and then top left and X and Y, and bottom right X and Y. So we got them. We're calculating those just from the screen width and height. So that's basically what we're doing there. With the image grab, you end up with an image, and to make it something that the face recognition and CV2 can handle, you have to change it using an NP array and change it into an NP array. So once that'll give us the image that we can work with. And we change it to the AI BGR so we can use that. And basically this part is just all the same as what we do for any image that comes or snapshot that comes up. Putting a white rectangle so we can see our text, our blue text a little bit better here is all we're doing. Like I say, we're moving the window over to the right side of the screen, and basically that's all we're doing. Like I said, we're pulling our region of interest is going to be always from the left side of the screen up here. They call it a bounding box with image grab, so that's the B box. So, all right, so we can run it and see how that works. Kind of cool that it works so good. Like I say, we got that, and got our track bars. They're both set to 100, and I'm going to leave them like that. I think you could do away with them and just leave your region of interest wherever you think it is, and move your window around. I think is just as easy as moving the bounding box around. So so when we start out, like I said, all it's seeing is the program window, a section of the program window over here. So like I said, I got a small browser window that I did, and whatever's on that browser that's in the screen, you can pretty much see. And like I said, if we wanted to move the browser around, you could just move the browser. So I just left them in, but they're pretty much don't need to touch them. All right, so this is like a video that you can play, and it just.
It's a very large expenditure for people.
You can see we're down to like 1.4 frames per second. So I put our frames per second, I rounded it to 1 decimal place in our code. So that since we're so low, I just, every tenth matters, I guess, at that point. So we got that. We'll stop that. And you can also, like I say, this is an image, searching for images on Google. And it does it. I brought this one up because I think it's kind of funny that this one in the back here looks like, I don't know who that is, but it might be Pence. I don't know. But the program thinks it's Paul McWhorter. So I guess Paul's a celebrity there. But anyhow, so we can just move this around and then this updates and pulls in who it is and everything. And like you say, when you get multiple faces on there, it slows it down even more. So we're down to 0.8, 0.7. Let's see. So it got. It's picking up Joe Biden and 3 Anthony Fauci's there. I didn't pull anybody else up, but you can just see. Let's see if it gets Donald. See if we can pull Donald into it. Whoops. So we could actually use this bounding box here to move it up a little bit if we wanted to. So yeah, I did. We picked up Anthony Fauci and Donald Trump there. So it's picking up the people we needed to pick up. Works pretty well, but that's enough of a thing for my homework. We'll quit out of that and everything. So that's my homework for the week. I enjoyed it, and thank Paul for all he does, and look forward to the next one.